Okay guys, today's video is going to be pretty long because we're going to handle following the player with the camera, camera rotations, and camera collisions. So let's right click on our main camera object in the scene, create a game object, and then drag it out from and under it. I do this so it's on the same transform as the camera. Then I'm going to call that camera manager. I'm going to right click and create an empty game object. I'm going to call this camera pivot. And then I'm going to drag the main camera in under the camera pivot game object. And I am going to create a script on the camera manager game object appropriately called camera manager. And don't worry about what we have a game object called camera pivot. That will make sense when we actually start writing these scripts. So let's open up Visual Studios and jump in. Okay, first off, I'm going to erase the start and update method. Just going to have a blank, clean script here. And the first function we're going to create in the script is going to be called public void follow player. Or if you want to, you could even call it follow target, because you could use this for anything that has a camera following it. So I'm just going to keep mine and call it follow target. We're going to open up these curly bracers here, and then this function will be very simple. We're going to say vector3 target position is equal to vector3 dot smooth damp, which is a function used to move something softly between one location and another, usually used for a camera in game. And then we're going to open up some brackets here, and what you see, we need a current position, the target position, a reference for current velocity, and a float for smooth time. So let's start off with the current position. Well, the current position obviously will be the transform dot position, which means the transform of this game object that the script is on. So our camera manager. So wherever our camera is now, and then we're going to need to make something called the target transform dot position, which we don't have made yet, and that will obviously be our player. So we want to move this from the current position it's in towards the position of the target transform, or the transform of the player. So let's make a public transform variable, and I'm going to call this target transform, as we just said right there. And then I'm going to write here the object the camera will follow, just in comment, in case anyone is lost or forgets. So next we're going to need a reference for the current velocity and smooth time. So for current velocity, it is quite simple. All you need to do is make a private vector3 and just have it called camera follow velocity, or just reference velocity, and enable it at vector3.0. And then let's put there camera velocity, and then we need a float for our smooth time. So we can actually make a variable for that. So let's do that. Let's make a public float follow speed. Now let's initialize that at say 0.2f. I'm going to actually change that to camera follow speed, so we're very clear in our naming conventions here. Okay, and we're actually good. We just need to add the keyword ref, which I forgot to do, in front of this current velocity, as the error says down there. Okay. Great. Now we need to do a couple more things for this to actually work. So I'm just going to hit enter so you guys can see that on the screen very clearly, so it's not dragged off of the screen. And then below here, what I'm going to say, so to recap, this vector3 target position variable is going to update to the player's position from the current position that it's in right now. And then we need to set the actual position of this game object, so transform.position, to the target position variable we just made. Now this function will be called on the late update method, which updates after each frame. So as you can see, because of this functionality, the position of the camera will move towards the player after every frame has been processed. I hope that makes sense. Now on the awake method, let's actually call that target transform. And what we can say is equals find object of type, and we can actually use the player manager, and then we can say dot transform, because there should only ever be one of these in the scene. If you want to, you can also just make it a public variable and drag in the player itself. Okay, let's save that. And now over here on the player manager, we're going to actually make a variable of type camera manager. We're going to call that camera manager. And then on the awake method, we're going to initialize this by doing in similar fashion, camera manager equals find object of type camera manager, because there should only be one of these in the scene. Now, if you want to, you can make it public and drag it in via the inspector. It all works the same. So We're actually going to use late update for our camera, as that is what is recommended when using fixed update for physics on rigid bodies. So let's make a private void late update, which works like update, but instead of calling it during the frame, it calls it after the frame is ended. Then we're going to say camera manager dot follow target, and let's save. So we have a bit of a problem. As you can see, the camera does indeed follow us, but it shoots right to our feet, and we don't want that. Well, luckily we have our camera set up so we can kind of edit where it rests. So because of our script, it actually doesn't matter where the camera manager game object rests. It will always find its way to the player. So because of that, I'm just going to reset its transform. You can put this anywhere in the scene. Now what does matter is the camera pivot and the main camera values, because those will not be reset. So we can use the camera pivot here to adjust our height. I'm going to put mine at 1.7. And then we can use the main camera itself, the main camera game object, to adjust the depth. Or the Z, which I will put mine at -3. So if you ever want to adjust the height or the depth of the camera, you can adjust them here on these game objects. Now, if we press play, as you can see, we have the camera that follows the player. If you look though, our player is kind of stuttery. You see that? So we're actually going to fix that right now. That is the thing with the rigid body. So let's go off of here and go to our game object where our player is, and go to the rigid body, and actually go to interpolate and turn it to interpolate. I'm not sure why doing this stops the stutter with the camera. I just know via documentation it needs to be done. If somebody knows a lot about this and could type it up below, I would be very interested in reading it. So as you can see, we have no more stutter with the player, and the animations are playing smoothly, and that looks a lot nicer. Now, before I move on, I'm actually going to quickly change the layout of this little level I've created, because the white is burning my retinas. It is so reflective and bright. So I will fast forward the video and I will be right back. Okay, with that out of the way, now let's get back to the camera. Let's add some rotations, so when moving around we can actually turn the camera. So I'm going to hop back out here into the camera manager script, and now we're done with this follow target function, so I'm just going to create a new function called public void rotate camera. Let's open that up, and we're going to need to make a few new variables. So let's do some thinking here. We want to rotate it with the joystick. Much like we handle our movement, we got to feed it some values. So let's come up here first. Let's make a public float. This is going to be called the look angle. And then we're going to make a public float, and we're going to call this the pivot angle. Okay? Now we're going to use one of these to make the camera look up and down, and the other to make the camera look left and right. Alright, so let's go to the rotate camera function here. We're going to say look angle equals look angle plus, and we're going to say something like joystick X input, because this will be a right stick. And honestly, you could even say something like mouse X input or camera X input. And then we're going to times that by the camera look speed. So don't worry, none of these variables actually exist yet. We're just writing them out to kind of get an idea what we're going to do. Now, before we move on, we also need to do something with the pivot angle. But I'm going to change joystick X input to mouse X input because we're going to be using our mouse to move the camera as well. I think that just sounds neater. You can call it camera X input or whatever you'd like. Right below here, I'm going to say pivot angle is equal to pivot angle minus, then we're going to open up these brackets again, and we're going to say mouse Y input or camera Y input, and then we can say times camera pivot speed. And we haven't made these variables either, so don't stress. So much like how we feed our player's movement through the input of the joystick, and we split that into two axes here, the X and the Y, we're going to do the same thing with the camera's movement. So first we got to make the actual input for the camera. So I'm just going to comment this out so I'm not getting errors for now. I'm going to save it. And then we're actually going to go to our inputs, or our player controls, and we're going to add something here for the functionality of the camera. So let's open up the player controls, and we're going to go to the actions here. And as you can see, we have movement. And again, just like movement, this will be pretty much identical because we have a WASD here and a left stick. We're going to add an action here, and we're going to call that camera. Okay? And then what what we're going to want to do is we're going to want the mouse. So we actually need to change that first on the camera itself to a pass-through, not a button. And of course, it's going to be a vector 2, just like the movement, because we want two axes, the up and down or left and right. It's taking in the action of a joystick, essentially. So let's go here, and we're going to look for delta and get the mouse. So we can control the camera with the mouse, or if you're playing on the keyboard, or a joystick if you're playing on the controller. So we're going to add a 2D vector composite, and I'm just going to call this right stick, because it will be the right joystick. And then what we're going to do is change it to analog, and then we want to fill in the up, down, left, and right values here in the controls. So for that, we're going to search right stick, and then you can search /up, /down, /left, or /right. And you want to use the one that says gamepad, because that will work with most controllers. And then we'll do the same thing for down here, and left, and right. And now we'll be able to edit this right stick, the camera, we'll be able to edit the values of this, influencing it with our mouse or with the right stick on a gamepad. So just like with the movement input, we're going to say public vector 2, and we're going to call this camera input. And again, like on the previous video, if you're confused, go back and rewatch that if you want, on movement, not the previous video, the one before that. We're going to say player controls dot player movement dot camera dot performed, this weird syntax here, plus equals I equals greater than camera input equals I dot read value vector 2. And all this means again is that if you move the mouse or the right joystick, it will send those values to the camera input vector 2 variable. And from there, we're going to do the same thing we did with the movement input. We're actually going to split that into two separate variables for X and Y, and that's how we're going to move our pivot and our look angles in our camera. So see here how we have a vertical input and horizontal input. I'm actually going to go up here, where we already have these created, and I'm going to make a public float. I'm going to call this camera input X, and I'm going to make another one for camera input Y. Now you could call them camera vertical input and camera horizontal input if you'd like. You can call them whatever you want and keep the naming conventions consistent. I'm going to call them camera input X and camera input Y for the X and Y axes respectively. So down here in handle all movement input, I will consider this a movement input because we're moving the camera. I'm going to say camera input X is equal to camera input dot X. And then right above that, I'm going to say camera input Y is equal to camera input dot Y. So again, we're just basically taking in the input of our joystick, and we're putting that to the camera input variable. And then from there, we can split that into two separate variables for the camera input Y and camera input X, much like the vertical input and horizontal input from our movement joystick. And then from there, we can actually take these values and make our camera turn according to what they are. So let's jump back here in the camera manager script. And what we're going to want to do is actually call our input manager. So we'll make a variable of type input manager. I'm going to call it input manager. And on the awake method, I am going to use input manager equals find object of type input manager, because again, there should only be one of these in your scene. It's on your player. If you'd prefer, you can make the input manager variable public and drag it in via the inspector. There are many ways. Nothing wrong with doing either. So I'm going to come down here. Then in rotate camera, I'm going to uncomment out this line here, and where it says mouse X input, I'm just going to say input manager dot camera input X. Then we need to make our camera look speed variable. So let's do it up here as a float. So on right below camera follow speed, let's make a float camera look speed. I'm making all of these public so I can adjust them in the inspector. You can do CLI field if you want. I know some people like that. I'm just going to make them public. So let's also go down here and erase these slashes, and we're going to say input manager dot camera input dot Y times camera pivot speed, which we don't have made, so let's make that as well. Going to copy this, and right below camera look speed, you can just copy that if you want and paste it, and we can just say camera pivot speed. Now let's save that. Now we actually also want to change these to private. And you're going to get an error on your player manager after we do this, because it won't be accessible to the player manager. And what we're going to do is make one public function called public void handle all camera movement. And think of this like the tick update in our input manager. We're just going to put all of the functionality in this one function. And then instead of calling all the individual functions on the player manager, we can just call this one. So if you minimize the Visual Studios now, you're definitely going to get an error in the, there it is, double click it, and it will tell you that this is inaccessible due to its protection level. So instead of follow target, we're going to say camera manager dot handle all camera movement, which encompasses two of these functionalities. Okay, so now back to the rotate camera function. Let's finish doing this. What we're going to do is we're going to say vector3 rotation is equal to vector3.0. So we have a vector3 with zeros on all of its positions. Then we're going to say rotation.y, so the y position of this variable is equal to the look angle. And then we're going to say quaternion target rotation equals quaternion Euler rotation. So that will give us an actual rotation variable, and then we can say transform dot rotation is equal to target rotation, and that will make the camera rotate towards the rotation we just made. And then right below, in similar fashion, but with the x-axis, we're going to say rotation equals vector3.0. So this is the same rotation variable that's up there. We're just resetting it to 0 again. And then right below that, we're going to say rotation.x is equal to, you probably guessed it, the pivot angle. Right. Then we're going to say target rotation equals quaternion dot Euler rotation. And then we're actually going to have to call upon the transform of the pivot game object, the camera pivot game object. So we don't have that made, but for now let's just say camera pivot, whoops, not speed, dot local rotation equals target rotation. Make sure you say local rotation, because that's the rotation of that game object specifically, not its rotation in the world space. That's important. Okay, so let's go up here. And then right under, I'm going to say right here, we're going to say public transform camera pivot. You can call it camera pivot object if you want, or camera pivot transform. I'm just going to say the object the camera uses to pivot. All right, we're going to minimize this now and go to the inspector, click on the camera manager, and we're going to drag in the camera pivot to the camera pivot variable. And now I'm going to show you something. If I highlight the camera manager and I rotate it, if I rotate it up and down, as you can see, the X value on the rotation changes. And if I rotate it left and right, you will see that the Y value on the rotation will change. And these will be the values we're going to edit in our camera manager to make our camera rotate. So if I hit play now, as you can see, we have rotation in our camera. And that's nice and neat. Looks good. Now there's a problem. Oh, look at that. We can rotate forever, and that is giving me vertigo. So we're actually going to make a limit on how far we can rotate on the position of going up and down, but not left and right, because we should be able to rotate left to right infinitely, but not up and down. So let's jump back in the script here, and what we want to do is limit the rotation on our pivot angle. So the rotation of us going up and down. What we're going to do is we're going to say mathf clamp, and that clamps the possible pivot angle between the minimum and maximum values you assign. So we can essentially assign a minimum clamp and a maximum clamp, meaning it has to be at least this, but no more than this. And what we're going to do is pass through our pivot angle, and then we're going to make two new variables, and we're going to call it minimum pivot angle and maximum pivot angle. And then after doing so, and we assign proper values to these variables, it will make it so our pivot cannot go outside of these values. So I'm actually going to make these now as floats. Let's go up to the top here, and right below this right here, I think we'll do, I'll say public float minimum pivot angle. I'm going to initialize that at -35. In my experience, this is very nice looking and tends to ring up at a good spot. And then I'm going to say public float maximum pivot angle, and I'm going to make that +35. Again, I like this. You guys can adjust this as freely as you want. You can make it whatever you want. So I'm going to come down here again now, and we're going to save that, and I'm going to start the game. And if you watch, I can only go up and down this high, but I can spin around left and right forever. So we almost have this done now. If you look though, we can kind of put our camera through the walls. We can add some form of collision detection, a very nice, lightweight, simple one for now. And let's do that. This is a little more advanced, so don't feel bad if you don't quite understand everything that's going on. Just take your time and try to experiment with stuff by yourself. So I'm going to say public, or private void rather, handle camera collisions. I'm going to try to make this as clear as I can. So what we want to do is essentially, and before we move on actually, I'm also just going to take this here, this vector3 rotation variable, and I'm going to place it up the top right here, and then I'm going to erase this part of it. And what I'm doing this for is to keep it all looking consistent, because essentially this is the same functionality twice, just editing different values, and it might look confusing to new programmers if you see like this, but now as you can see, this is exactly the same, except we're editing the Y transition on one, the X on the other, but the functionality still works pretty much identically. So I hope that is clear. Now on the private void handle camera collisions, this is essentially going to take the camera and move it if it brings up against an object. So push it forward or backward. We can say float target position. I'm actually going to initialize that and say equals default position. Now what's the default position, you might ask? Well, we actually have to make that, and that is going to be our camera's Z position. So let's actually put this up here. I'm going to say private float default position. And this will be the position your camera comes back to all the time. So on awake, what we can do to reference that is we can say default position is equal to camera transform dot local position dot Z. And the camera transform, we can actually make that up here too. Let's make that right here. Private, public, sorry. If you want to drag it in, transform, camera transform. So now you can drag it in the inspector, or optionally, we're going to say this, or the transform of the actual camera object in the scene. If you don't want to drag it in, you can also come out here and make sure you say it before default position. We're going to say camera transform equals camera.main.transform. We have to call it before default position because default position uses that variable. Otherwise, you would get an error. So as you can see right now, the Z position is -3. So the camera is always going to come back to this depth after it brings up in an object, and it's free of collisions. Basically what I mean is when you bump into something, it will get closer or pull further away depending on what object you're bumping into, but it will always reset at -3 after you're away from any object it can collide with. That being the case if the game starts off the camera at -3. Okay, so back into the script here. I hope that is clear. We're going to say raycast hit. We're just going to call this variable hit. And a raycast hit variable just stores some information when you use a raycast. And then we're going to say vector3 direction is equal to camera pivot, or camera transform dot position minus camera pivot dot position. Then we're going to say direction dot normalize. Now we're going to say if physics.spherecast, and all this does basically is it creates an invisible sphere around the object that you want. So we need a starting point for this sphere cast, and the starting point of the sphere cast is going to be camera pivot dot transform. And the radius, meaning how big it will be, well, we can actually make a variable for that. Ideally, you want to have it pretty small. We're going to say camera collision radius. Well, let's copy this up here. We can make this as a float. We can make it public so we can adjust it in the inspector. I'm going to say public float camera collision radius. I actually initialize this at 2. This is me commenting off video. You should make it something like 0.2. I fixed that later, I believe, off camera. Make it pretty small. You don't want it too big. And then we're going to say comma direction, comma out hit. Then we can say math f absolute value, target position. So basically all this does is creates an invisible sphere cast starting around the camera pivot transform with a radius of say 0.2 is what you want to have. And then it fires out in that direction we just made. Then we say comma. We want to scan this on only a couple of layers. So what layers do you want to collide with in the game? You want to collide with your environment, your player. So we're just going to say collision layers. And we don't have that made yet. So we're going to go up top and make a public layer mask. And I'm going to call it collision layers. And again, this will be things your camera will collide with in the environment. I'm not going to initialize that on start or awake. I'm actually just going to do that in the inspector manually. So the layers we want our camera to collide with. Just so you guys can see what's going on, I'm going to put this down here, hit enter. End this here. Oh, that's supposed to be camera pivot dot transform dot position. Okay, so what happens if we do hit something with this sphere cast that starts off at our camera pivot dot transform dot position? The radius is 0.2. So if we hit something, we want to use this hit variable right here, this raycast hit, and get some information from it. Because when we hit something, we're storing the thing we hit on this hit variable right here. So that's what the hit variable is for. It tells us what we hit, and we can do stuff with that. So let's say float distance is equal to vector3 dot distance, not dir, distance, between our camera pivot dot position and our hit dot point. So what's the distance between our camera's pivot position and the thing we hit? Okay? Then our target position is going to be target position minus, in brackets, distance minus camera collision offset. And the bigger the offset, the bigger the distance is going to push away from the object. So what I'm saying is, let's make a public float here called camera collision offset. If you have the offset to 0.2, when you bring up against a wall, it'll jump off the wall a little bit. If you put the offset to like 20, it'll jump off of the wall by a lot. So keep this relatively low as well. I find a lower value works nicer in most cases. So how much the camera will jump off of objects it's colliding with. I hope that makes sense. All right, next. Let's go down below this if statement, and we're going to say if mathf absolute target position is less than minimum collision offset, then target position equals target position minus minimum collision offset. So basically we want it to jump off of something. If you want it to jump off of an object at minimum amount, you can use this variable. So let's go up here and let's make it right below here, public float. I'm just going to call this minimum collision offset. I'm going to make that 0.2f as well. Now, in order to edit our Z position on our camera, which is what we said before, we actually need to make a private vector3. And we're going to call that camera vector position. See, we can't edit the Z position using the transform. We have to make it a vector3 for that reason. So down below here, we're going to use that. We're going to say camera vector position dot Z. Now we can edit this one position on that equals mathf dot lerp between camera transform dot local position dot Z and target position. And then we can do that by a time. And I'm just going to say 0.2f. You can make a variable for this if you'd like. And then we can say camera transform dot local position equals camera vector position. And now you have a way to collide with environments in your game. But we're not quite done. We actually have to pick the layers we want to collide with. So let's save that. Let's minimize that now. We can go up here and we can actually, under handle all camera movements, say handle camera collisions. Now let's save that. Let's jump in game. On the camera manager, under collision layers, I'm going to add, whoops, not everything. Oh, anyway, let's go to our player first. Let's make another layer for our player or character. You can call this player or character if you have multiple of these things. And then under camera manager, let's go and hit nothing to reset them all. And I want it to collide with the default layer and the player. These game objects, see, are under the default layer. All the walls and floors and stuff I've made. I'm actually going to come back in here and get rid of this, equals minus. And there we go, save that. Now, let's move this up. And if we hit play, as you can see, if I move the camera close to the walls, it gets closer to our player because it brings up in the walls. And there you go. So now you have a camera that rotates, it follows you, and it brings up with things in the environment. I hope you guys found this video helpful, and I hope you took away something from it. I hope I made these concepts as easy to understand as I possibly could for beginners especially. So guys, as usual, if you did enjoy the video, don't forget to drop a like. It helps my series a lot and helps other people who want to jump into this stuff find it much easier. If you're feeling super generous, leave a comment to appease the YouTube algorithm gods. Helps even more. And if you're feeling like a total champion, check out my Patreon below. I will see you guys in the next video.